Now we're going to look at logarithmic equations. There's a lot of different ways that you can solve these type of equations, but the methods I put here will work for all of them. So let's get started. First thing, you've got to move all log terms, terms that contain logs, to one side of the equal sign and all the constant terms to the other. So there's a separation here. Step 2, condense log side down to just one log. Remember when we were doing QProp, that's one of the reasons why we did it, is for this right here. Once you've condensed it down, you've then got to rewrite last equation into exponential form, and we're almost ready to solve the thing. So let's go ahead and get started. In this one, if you'll notice, I already have just one log. So now, since I've only got one log, I don't have to do step 1 or step 2. So step 3, let's rewrite this into exponential form. My base is 5, exponent 2 equals my number. Come on. And if you'll notice, it's back to something that we have done. 5 squared is 25. Divide both sides by 5. X should be 5. Now to check this, it takes a little bit longer because a lot of these are not the nice bases that we have on our calculator. So let me store 5. Actually, in this one, I don't really need to do it in the calculator because I could put 5 here. That would be log 5 squared base 5, and the exponent is what it's equal to since my number and my base are the same. But I wanted you to see how we have to check it via a calculator. I have to use change of base theorem. So I'm going to do log of number divide by log of base. So log of number, 5x, divide by log of base. And it should give me my 2. There. Alright, let's try this one. I've got logs all over the place. So I'm going to bring this log over to the other side, and if I do that, I'm going to have 0 left on the right. Now doing QProp in reverse, I look for powers. Powers are located in front of the logs. I do not see any. So after powers, I have products. Got a product here. Remember, it's indicated by addition. So this is going to be condensed down to log x times x plus 2 base 2. And I still have this. And now the last thing is quotient. So I'm going to get this down to one log. Let me get rid of my box. Okay, now here, I'm going to have to now, since it's down to one log, rewrite this to exponential form. Base is 2, raised to the 0 equals my number. And hopefully I went here with that. Oh, very good. 2 to the 0 is 1. And if you'll notice, I made it into a fraction because 9 times out of 10, you're going to end up with a fraction here. You can have a fraction here. And if you remember, I can cross multiply. So probably that's what I did. Probably, I know it is. I did over here. I cross multiplied 1 times that piece and 1 times that. And since it's a quadratic, now guys, these equations are going to go back to either linear or quadratic. So everything that we've done prior to this, we're going to use it here. This does factor. I'd have, what, x plus 3, x minus 2, and set them individually equal to 0. Now I've got to check these. Step 4, solve and check. At least the minimum is see if your variable that equals a negative will work. If you substitute it in, you would have log of a negative, and if you remember, I have to take log of positive numbers. So this one does not work. Only x equals 2 works. I learned how to do an x on the computer. Is that cool? Alright, so 2 does work. Store it in. Let's see. Let's see if we can do this by, in our head. If I put 2 here, that would equal 1. 2 here would be 4. And that would be log 2 squared. So this would be 2. So on this side, I would have 3. On this piece, I'd have log 8. 8's the same thing as 2 to the 3rd. So log of 2 to the 3rd base 2, that would equal 3. So 3 does equal 3. Got some more. A couple of things I could do here. Now, I could take the 3 back in, but since 3 is multiplying, I can divide both sides by 3. I've got options here. Okay, now I've got my log all by itself, so this would be e raised to the 10/3 equals 5x. Well, guys, I know e to the 10/3 is a number. So for me to solve for x, all I need to do is divide both sides by 5. And then I can get an approximation in my calculator. Let's see, second e raised to the 10/3. And then divide that by 5. And there's my answer. Let's store this one, because I'm going to go back to the original, and I do like those that have base e and base 10 because I can check them real quick in the calculator. So 3 natural log, let me put 5x, and let's see if we end up with 10. And there it is. So I put a little check there. Alright, more than one log. Congregate all logs to one side, numbers to the other. So I'm just going to add this log to both sides. Got to condense. So remember, this right here, addition, means I can rewrite these as a log of a product. And I can go ahead and square that. Now, next thing I have to do, let's go back up here. Once the log is condensed, you get one log, you've got to rewrite that equation into exponential form. Here, the base is understood to be 10. So 10 squared is equal to that. 10 squared is 100. When you have a quadratic, you've got to get everything over to one side. So I'm going to subtract 100. And now I'm going to factor this. And most of them do factor. You can use quadratic formula if you like. This one does factor 2, x plus 19, x minus 10. Set them individually equal to 0. If you'll notice, I've already x'd this one out because if you put it back up here, you get log of a negative. That's a no-go. So gotta just x it out. Don't erase, just exit. And that should be my answer. Well, let's store it in and see. And this is nice because I do have a log x minus 6. I don't have to use change of base theorem. See what that equals. The other side, I've got 2 minus log x plus 15. Since my answers are the same, that is my correct answer. Okay, let's move on down. 2 more examples. I've got my log already isolated, so rewrite this. Base raised to exponent equals my number. This is linear. If I don't see an exponent too, it's linear, and that's one of the nice ones. 5 cubed is not 15, it's 125. Subtract 8, and then divide by -7. And that should be my answer. This one, let's see. Now, if you'll notice, I do have a negative here, so don't automatically X out any negatives. Look what happens when you put this back in here. You multiply by a negative, so you end up with a positive. So let's store this. -117 divide by 7, storing for x. And I've got to use change of base, so log of number divide by log of base. Log of number, 8 minus 7x, divide by log of base. And there's my 3, so that works. Last one. I've got, all my logs are already on one side, so I've got to condense. So this, remember, is a quotient. Come on, box. So rewrite this. That would be 10 to the -1 is equal to that. And 10 to the -1, remember, is 1/10. Cross multiply. I reproduced it. Now I cross multiply. So I've got 10x, and 1 times this will give me that right back. Subtract x. It looks like x needs to be 1/3. Well, let's see. 1 store 1/3. 1 divided by 3. Storing for x. Log x minus log x plus 3. And see if it equals a -1. And it does. So there's my answer. And that's it for logarithmic equations. Thank you.